All right. Um, let's get started. First question is a solve for x, ne? Yeah. And the nicest thing, we were just doing a video about solve for x, so we're good. Uh, right. Cool. So here you're gonna have 3x, right? 3. Man. This is 9. 3 times 3, that is 9. So 9x, and then plus that is 6. Let us transpose. Right, 9x minus 6. So then what we can do is, what can we do after? We have 0. Then after here, it's you looking for the factors. Right, start with 1, 1, 1. Let's go for 2, 2, 2, maybe 3. Okay, 4, and then I shift. If 4 doesn't work, I'm shifting. What? 4 doesn't work. Let me try 5, and then I shift to negatives. 5, 5, 5. Cool. So -1, -2. Yes. -1, -1, -1, -1, what? So it's this, then this. Cool. -1 almost worked, but nope. Please, man, work. Thank God. Yo. So -2, -2, right? X plus 2, right, is a factor. And yeah, we then do what? The long division. Ne? X to the 3 divided by x squared, x, then x squared multiplied by 2 plus 2x squared. Alright, we have 0 this side, then we're going to have minus 3x squared. Bring down the rest. We do our thing, we get minus 3x, multiply minus 3x, then minus 6x, right? 6 here. This is 0. Here it's minus 3x, right? And then we do the math again. Minus 3 minus 3x minus 6, we get 0. So we're still good. We then say therefore, no, not therefore yet, x minus 9x minus 6, right? You then say therefore x plus 2 x squared minus 3x minus 3. Ne? Cool. So yeah, ne? So here you have x minus plus 2 equals to 0, ne? Or x squared minus 3x minus 3 equals to 0. So now here you can just say x equals to minus 2, ne? And then the thing is here, ne? The issue here is, are there any two numbers when you multiply you get 3? When you add or subtract, you get minus 3. Before you answer, just remember 3 is a prime number, so it only has one pair of factors, 3 and 1. Alright, so 3 and 1, you multiply them, yes, you get 3, but add or subtract these 2, you will never get 3. So however, then I would say probably this is factorizable, right? In case it is not, we are yet to see, but in case it is not, you will then say under this one, you will then say no solution, right? But before you can come to that conclusion, let's use a quadratic formula, ne? Yeah, let's use a quadratic formula. Quadratic formula say x is equals to minus b plus or minus square root of b squared minus 4ac 2a, right? Minus b, that is it's gonna be a positive 3 plus or minus square root of, you have minus 3 squared minus 4 into a, which is 1, b, which is minus 3, then 2a, which is 1. That means you have 3 plus or minus square root of I would say minus 3 squared minus 4 into 1 into minus 3, right? You get 21 divided by 2. Then x is going to be, let me see, square root of 21. It's just square root of 21. So therefore you have x being 3 plus square root of 21 over 2, or you have 3 minus square root of 21 over 2, and there you're done. Yeah, so it does have solutions there. So there is no way, you can't really say that no solutions. But if you did this and you found out that you had a negative inside your square root sign, then you'd conclude to say no solutions, right? So let's do this one. For the sake of not making the video long, we have done a lot of software X's, ne? So I don't know which one is interesting here. Let me see. I don't know. Okay, I'm gonna pick this one. It seems a bit more interesting. I mean, this one still is in a way, but yeah. So we're just gonna do this one. We skip this one, then we go to the other questions. So here we have 2x to the power of 3 minus 3x squared minus 8x. I'm going to transpose minus 3 equals to 0. So then we look for a number. Minus 3 minus 8 minus 3. Let's start with 1. Can we? Yes. 1 doesn't work. In fact, while I'm at 1, I can just say minus for minus 1. Oh, minus 1 works. So 2 minus 1 minus 1 right? So therefore x minus, x equals to minus 1, x minus 1, x plus 1 is a factor. So yeah, x plus 1 is a factor. Cool. So then you do your long division. X plus 1 minus 3. Here you have 2x squared. When you multiply, you have 2x 3 minus plus 2x squared. I forgot the squared there. Yeah, this is 0, and then here you have minus 3 minus 2, so that is minus 5x squared. I bring down the rest, and you do that, that is minus 5x squared x, bro, minus 5x squared minus 5x. Then we subtract. This is 0. We have minus 5 minus 8 plus 5, so which is minus 3x minus 3 minus 3 minus 3x minus 3, right? And you get 0. So that means you have x plus 1, right? And then 2x squared minus 5x minus 3 equals to 0, right? Then here you can do that factorization. You multiply 2 by 3, you get 6. Factors of 6, that is 6 and 1, 2 and 3, and this pair can give us these values, 9. So because then minus 6 plus 1 equals to minus 5. So we x plus 1, big bracket, then you have 2x squared minus 6x, right? Then you have a plus 1 plus x minus 3, right? Yeah, and then you group this and you group these, right? X plus 1 here, this is, you take out a common factor here. Let me do my big bracket. You take out a common factor here, you have 2x, then you have 1, you have x minus 3. Here you can say you have x minus 3, then your big bracket equals to 0, equals to 0. Then here you have x minus 3, oh no, you have x minus 3, you have 2x, you have 2x plus 1 equals to 0. So therefore x plus 1 equals to 0, or x minus 3 equals to 0, or 2x plus 1 equals to 0. 2x minus 1, x minus 1 over 2, yes it is, x equals to 3, x equals to minus 1. So we're good. How's it? Let's continue. Yeah. Show that this x minus 2 is a factor of our polynomial. Né? Let me define my polynomial to say this is a of x, right? So from factor theorem, we did say if a of x, right, is divided by, yes, I mean, yeah, right, if a of x is divided by this, and remainder of x is 0, ne? Then b of x is a factor of a of x. Another better way of saying it is that if you have a of x, ne, and then you have b of x now, which is cx minus d, then you find out that cx minus d equals 0, dx, then x is therefore equals to d over c, right? Now when you take a of d over c, then you get 0, then you know that this is a factor of a of x. And yeah, because also something, okay, now I'm talking about the factor theorem. Let's go to the remainder theorem. Remainder theorem, it says that if you take d over c, you substitute it on your a of x, your polynomial, whatever you get is going to be the remainder, right? So if the remainder is 0, that means whatever you divided by, or whatever you have you could divide with, is a factor of your polynomial. So now these guys, they are asking us to say, prove that or show that x minus 2 is a factor. X minus 2 is a factor of this polynomial a of x. So what we do is we say that equals to 0, x equals to 2. Then we like a of 2 is going to be 3, 2, 3, 11, 2, 2, 2, 4. Put that in a calculator. Minus 11 plus 12 minus 4. And we get 0, right? You then say, therefore, x minus 2 is a factor of a of x, our polynomial, right? And if it is our factor, we know from the previous video we can use x minus 2 in our long division to solve for x, or to factorize, which then helps us to solve for x. So yeah, we have this, and then now let's go, you divide, you get 3 x squared multiply 3x3, then you have minus 6 x squared. This is 0, and right here you have minus 11 minus 11 minus 5 minus 6, then the answer is minus 5x squared. Bring down the rest, divide, you get 5x multiply minus 5x squared plus 10. It's negative and negative positive, right? Cool. Minus, that's negative. We minus 12 minus 10, that is 2. Maybe let me do a proper line so I can say 2x minus 4. Do the division, we get 2, we multiply, we get 2x minus 4, we minus, we get 0, right? From the 0, then we say, therefore, I still have space, which is good. You then say 3x cubed 11x squared plus 12x minus 4 equals to 0. Then you say, therefore you have x minus 2, you have 3x squared minus 5x plus 2, right? And what we do, we take 3 and x minus 2, and then we take 3 and 2, just 3 and 2, we multiply them together, 3 times 2, that is 6. Factors of 6, 6 and 1, 3 and 2. From these factors, oh, what? Okay. Yeah, we multiply these two, we get 6, and then from these two factors, we look for factors that if we add or subtract, we get the middle number, we multiply, we get the last number, right? Both of them, when we add or subtract, we can get this. Here, both of them, minus 3 minus 2, that is minus 5. Here, minus 6 plus 1, that is, right? But none of the pair, it gives us 2 when we add or subtract. That means what? We're going to have to go for quadratic equation, see what we get. Ne? So you would then say that equals to 0 or 3x squared minus 5x plus 2, right? And then x equals to 2, then here equals to 0, then here x equals to minus b plus or minus square root of b squared minus 4ac. You have 2a, and then that's minus, so you have 5 plus or minus square root of, it's 5 because we have minus here, so minus and minus positive, so minus 5 squared minus 4 into 3 into it's 3 and 2, right? And then 2 into 3, 5 plus or minus 25, this is 12, and then 24 minus 24, 6. You have 5 plus or minus, that is 1, so 1, 6. What is happening? It looks like we have factors of these things after all, right? So that is, therefore you have 5 plus 1 over 6 and 4 over 6. I mean 5 minus 1 over 6, which here you have 6 over 6, which is 1. Here you have 4 over 6, which is 2 over 3, right? So what am I trying to do? Yeah, so your values for x is this one, and this one, right? So what I'm gonna do it now, I want to test them, and we have 1, so I'm gonna test 1. So 1, it works, ne? 1, it works. Then let me try 2 over 3. Oh, and it works. Yeah, no, that is nice. That is nice. So yeah, these are the values of x, and they work. But I want to see like how we could not. Yeah, so we are fine, the work. I just want to test this thing last time. You have 3x squared minus 5x plus 2. So you multiply these two, that is 6, so 6 and 1, and then you have 3 and 2, both of them which are factors of the product. Both of these pairs, they can give us minus 5 adding or subtracting, but none of them will give us 2 when we multiply. No, that is okay. That is okay. So when you are at a point like this, then you would go for your quadratic equation, and yeah, it will do wonders for you. I think we have another interesting question this side, right? So this one, they say this gentleman, this is our polynomial, and here there's our quotient, and here this is our divisor, right? This is our remainder. Just remember the form, right? And then they say, what is the value of r, ne? Which is the remainder, right? So we are trying to find the value of r, right? Yeah, this is just one question, right? We'll come to these ones. So here, to find the remainder, you would say 2x minus 1. You are doing the long division, or you could use your synthetic, right? Yeah, you could use your synthetic method, but I like long division. It's long, but yeah, that cool. Now I'm dividing here. I'm gonna get x squared multiply 2x3 minus x squared. Then I am subtracting 0. This looks like I will get 0 here. 2x. Well, what can I do? So this is 0 and this is 0, so I have 0x squared minus 2x plus 2. Then what's up? Oh, then I'm gonna have plus 0x, then I have 0x squared plus 0x. I'm subtracting, won't make any difference. Minus 2x plus 2. Then I do my thing there. I'm gonna get minus 1. I have minus 2x plus 1. Then I'm subtracting. I'm gonna get 0 and I'm gonna get 1. And that means, therefore, r of x is 1. That is my remainder. That is cool. So we know that the remainder is 1. Just want to show you something, right? So let us use the remainder theorem now, because when you know the remainder theorem, you don't have to do all the hard work. Yeah, that may or may not be required. I don't know, but yeah, you may not have to do, like, there's a shortest way of getting to the answer, né? So you know that you would say 2x minus 1 equals to 0, 2x equals to 1, x equals to half. And then you substitute half, so you have 2 1 over 2 squared 2 1 over 2 plus 2, right? So 2, I'm just gonna say 0 0.5 plus, is it plus? No, minus 0.5 0.2, yeah, 0.5 it's a minus again, minus 2 0.5 and then plus 2, and then we get 1, right? So yeah, here I'm trying to emphasize the idea that, you know, the shortest way is to get there. Take it. And then here they say use the factor theorem to solve the following equation. So you're solving for m here. So factor theorem, how you do it, right? We're gonna try to find the factors of that. So you could say 8 plus 7 minus 17 plus 2, right? find the values 1, okay, 1, 1, 1. 1 gives a 0, so you then come here, you say 8 into 1 plus 7 into 1, 17 into 1, right? Therefore m minus 1 is a factor, right? And then solving that, you have m. Bro, I'm gonna use x, man, come on. I'm gonna use x minus 1, 8x3 plus 7x minus 17x. There. Alright, cool. So we have 8x squared. We have 8x to the power of 3 minus 8x squared. Then we are subtracting. This is 0. This is 7 plus 8, which is 15. No, cannot. Yes, it is. 15. Bring down the rest. Do your thing. You get plus 15, right? 15x. So 15x minus 15x. 0, and then here it's gonna be minus 2x plus 2, right? And then we do our thing. We have minus 2, you multiply, minus 2x, then minus with minus, that's positive, so yeah, and then 0. So yeah, I want to say that if you try to find something that, oh, this is a factor, right? If you happen to find that a particular x minus is your factor, and then you do your long division, and then you don't get a reminder of 0, you did a mistake somewhere on your calculations, because you have to when we say that something is a factor of that polynomial, we are saying if we divide this polynomial by this thing we're claiming to be a factor of that polynomial, we are going to get what? We are going to get 0, no reminder, right? And if there's a reminder, it's not a factor, right? So you find out that you have a factor, that x minus whatever is a factor, you use it on your long division to find the quotient, and you end up with a remainder. You did a mistake on your workings, because if we use theory, you must not get a remainder at all. 8x squared, 15x, what's a plus, minus 2. And it's easy to make mistakes, bro. Sometimes you don't even realize. It has happened to me many times, right? Yeah. In the videos, bro, that I've cancelled, videos that I've deleted. Yeah. Okay. we are here. Cool. So this bracket, I just want to do something interesting, right? I'm already seeing the 2, right? Because now I multiply 8 times 2, I'm going to get 16, right? There's no number. Okay, there is no whole number, there is no whole number that we can multiply by another whole number that will give us 16, right? This is, I just realized something beautiful also. Guys, know it, né? When you have your trinomial and the last term is bigger, right? Let me see. Yeah, the last term happens to be bigger than the product you get when you multiply the coefficient of the first and the last term, right? You're going to use a quadratic. That quadratic formula cannot be factorized. Like, it can be, but like not with the methods we usually use. So you'd have to use a quadratic formula to get the values of x, like here. And remember also the previous example was like that. So yeah, the previous example was like that. Yeah, on this other side, let me see. Yeah, because we multiplied 3 by 2, you get 6, and then 6 is bigger than 2, right? So then we had to use a quadratic, and we got the values, and they worked. We tested them, they worked. So yeah, so you know that here x minus 1 equals to 0. Oh, and then x is gonna be minus 15 plus or minus square root of 15 squared minus 4 into 8 into minus 2 into 8. Then here you're going to have x equals to 1, and then let's cook this side. That's minus 15 plus or minus square root of 15 squared minus 4 into 8 into minus 2. We're getting 289, 16. And then square root of 289. Oh, nice. So here we're getting 15 minus 15 plus or minus 17 divided by 16. Therefore you have minus 15 plus 17, and then you have minus 15 minus 17, which means the answer here is 1 over 8. Is that it? Yes, it is. Yes. Then minus gives us 2. Right. Cool stuff. And the thing is now, so we get minus 2. No. Yes. Minus 2, and I wrote 2. So we can test minus 2, right? Because for minus 1 we know for sure. No, for 1 we know. Yeah, so now let's test minus 2. So we go 8 minus 2 plus 7 minus 2 minus 17 minus 2 plus 2, right? Now let's test positive 1 over 8, ne? 1 over 8, 1 over 8, 1 over 8, we get 0. So yeah, we are fine, bro. These, they work, and we are good to go. Our friends are saying hence, right? Hence, or otherwise solve for x, right? Yeah, solve for x. So do realize something here. So we have, okay, what we have 2, ne? Allow me to do this. X plus 1 raised to the power of 3. Yeah, this one is interesting. Plus we have 7, right? No. Okay, this one is interesting. So plus 7. I'm gonna have to find out what 7. Okay, 7.2 2x. Something will click, bro. Something is gonna click. This one is very interesting. So it looks like somehow they are connected. So the values, we had x equals to 1, we had x equals to -2, we also had x equals to 1/8. Cool. It's fine. Okay, let me say -17 to x. Okay, and then what's happening? +2, right, equals to 0. So I'm seeing something really interesting. All these numbers, they all have 2, right? So let me do this. This one, let me write it as 2. No. I'm gonna write this one as 2, right? I don't know which 2 is gonna actually work for me, because I could write it as 2, 3, and then 2, 3x, right? Ooh, damn, shit. This one was a brainer, bro. You, because I just yeah. So we have 8 here. 2 to the power of 3 is 8. So it's 8, and then multiply by 2, right? Plus 7 times 2, right? Minus 17. Come on. 2. Yeah, plus 2, 0. You. That was yeah, that was something. So at least now we have something, right? We have something. Look at this problem now. These are kind of like the same, right? I can write it down further and say this is 8 multiplied by 2x to the power of 3, right? And then plus 7, 2x to the power of 2 minus 17, 2x to the power of 1 plus 2 equals to 0, right? So yeah, and then when it's like this, I can say let 2 to the power of x be, I'll just use bm, right? bm w, and then therefore you have 8 m to the power of 3 plus 7 m to the power of 2, sorry, minus 17 m plus 2 equals to 0, right? So bro so this, right, this is exactly the same as this, and we did solve it, right? What did we find out? We used x, but of course x was in place for m, so I will say we had m equals to 1, or m equals to minus 2, or yeah, or we had m equals to 1/8, right? So now I can then say that therefore 2 to the power of x is equals to 1, 2 to the power of x equals to minus 2, 2 to the power of x equals to equals to, let me say 1/8. And then here, then I would say 2 to the power of, yes, then 2 to the power of 0. I am coming to this one, the one in the middle. Yeah, it's quite a very interesting equation. Here I have 2x 2 to the power of minus 3, right? And then I'm gonna come with this to this one. It will be the last one. Then here, I would say therefore x equals to 0, and then I'm coming there, and then here I would say therefore x equals to minus 3, right? But then for this one, I think the answer is no solution. The reason is, we can try to use log, right, for these. Remember, let me see. Yeah, I just want to see if you guys are taught these when, and then I can do the proper. Okay. Beautiful. So by the time you guys do this, you'd have done logarithmic rules or laws, right? And from them you'd know how to deal with this. So let's go. You're gonna have x is going to be log, right? Log what? This is the base and this is minus 2, right? Let's give it a try. No. Log 2 minus 2. We actually do have the answer. Oh, no. We do not. I almost thought we did. I knew we don't have the answer because of this negative, right? There is no way you can raise a positive value. Like, even when you think about it, right, before you become very mathematical, when you think about it, there's no way you could raise a positive value, raise it to a particular exponent, and it gives you a negative value. Impossible, right? So this I, right, is for imaginary values, right? These are the imaginary values or complex numbers. You guys will do them probably when you get to university, should you do maths. Yeah, but this is, because you see the I there, right? It's like, I just want to show you with this. So for here, we're just going to say no solution, right? Solution, no solution. I just want to show you something that you know doesn't have that, it's going to give you math error on a calculator is a negative square root. So you see, if I say -8, I'm getting this value, right? I and whatever. So which is an imaginary number. So these things you're going to learn about them when you get to university, right? Yeah, you're going to learn about them when you get to university. But yeah, no solution for this one. No solution at all. Yeah. Cool. So let's work on this one. Yeah. This one, they say if find the value of r if x minus 1 is a factor of that, right? And the q of x divided by x minus 1 gives a remainder of 8, right? Yeah. So before maybe I solve this one, I want to say this. Me personally, I have a problem with the way they structured this question. The reason is, the reason I have a problem with the way they structured this question is that probably they could have used a different letter, because now when they say x minus 1 is a factor of that. Okay. My problem have been resolved. Look, so if h of x was divided, if this was x minus 1, right, r would have been 0, right? R must be 0, right? But now they didn't divide by x minus 1, they divided by x minus 6. So yeah, or not necessarily divided, but yeah, like this thing is like h of x divided by x minus 6 is gonna give you the quotient. This is your quotient, and then plus the remainder, right? So that is fair. So I don't have problems anymore. Let's solve this. Yeah, initially I was like, what? Nah. This don't make sense. So yeah. So then we know that here with h of x, right, x minus 6 q of x plus r. R is the remainder of h of x if we divide by x minus 6, right? So now if I substitute, okay, from that remainder x minus 1 is equals to 0, x equals to 1. If I substitute 1 here, I must get 0, right? So h of 1 minus 6 qx plus r. I have to get 0 when I substitute 1. So that means here I have minus 5 times q of x plus r, right? So that means r is equals to 5 q of x, right? And then they say that if this divides q of x, the remainder is 8. That means if I go to q of x, right, and I substitute 1, right, because of this x minus 1, I go to q of x and I substitute 1, it's going to give me my remainder, right, which is 8, right? Then now I can go there and say what? Okay, so yeah bro, apologies again, because here when we substitute 1, we have to substitute 1 all over, yeah? And here I set q of x, it should be q of 1, and therefore here we also have q of 1, and because we substituted q of 1 here, it's gonna be 1. Wherever we see x, we're gonna put 1, right? And here we find out that q of 1 is 8, so we go there. So therefore r is gonna be 5 multiplied by 8, which is 40, and just like that you're done. So yeah, quite an okay question, but cool guys. I'll see you in the next chapter. Sure, and enjoy.